Here we have a regular hexagon and we have 6 semicircles inside the hexagon overlapping each other. When we say it's a regular hexagon, it means if one of the sides is 2, then the rest of the sides of the hexagon are 2 as well. And also, the interior angles of the hexagon are going to be the same also. And of course, when we talk about the semicircle, it means that this is half of a circle with the diameter of 2, meaning the radius of the semicircle is 1. Then, here's our game plan to find the area of the shaded region. We want to find the area of the hexagon and take away the area of the unshaded region or the white portion inside the hexagon. Let's get to work. To find the area of the hexagon, first thing we want to do is draw the diagonals. Next, if we label each of these central angles of the 6 triangles A, then we have 6A equals 360, or A equals 60 degrees. So that we know that one of these central angles, or this one right here, for example, is 60 degrees. Also, we know that this side and this side are going to be the same because they're both radii to the hexagon, which means that this angle here and this angle here, which we could call it B, are going to be the same. So we have 60 degrees from the central angle here, plus B equals 180, since 3 angles of a triangle add up to 180. Then we have B equals 60 degrees as well, which means that it's an equilateral triangle where if the base is 2 of that triangle here, then the other 2 sides are going to be 2 also. To simplify, let's go ahead and draw that triangle down here. Using this triangle, what we want to do is find the height of that triangle so that we could find the area of that triangle. So if we were to label this H as the height of the triangle, then using the red triangle, which will be half of the base, this will be 1. So then we have H square plus 1 square equals 2 square using the Pythagorean theorem. Then we have H equals square root of 3. Right there. Then the area of that triangle will be 1/2 times the base, which is 2. Remember, we're trying to find the area of that triangle right there, so the base is going to be 2, times the height that we just found, or root 3. As you can see, the half and the 2 cancels out, and we end up with just the root 3. But check this out. We have 1, 2, 3, 4, 5, 6 of the same triangles, which means that the area of the hexagon will be 6 times one of the triangles, or 6 root 3, since root 3 is area of one of the triangles. So there you have it, folks. That 6 root 3 is going to be the area of the hexagon. On that note, I want to give you an important formula that you want to know, is that when you have an equilateral triangle such as this, and if we let the size of the equilateral triangle be x, the area is going to be x squared root 3 over 4. This formula is handy when you're looking for the area of a triangle in order to quickly find the area of a such thing as hexagon. If we were to use this formula on that, it would have been 2 squared, because the side of the triangle, or the equilateral triangle, is 2, root 3 over 4, and of course 2 squared and the 4 cancels out, and we end up with root 3, the same answer. So there you go, folks. Here is the area of the hexagon. Now let's go ahead and find the unshaded portion of inside the hexagon to complete the problem. To find the area of the unshaded region inside the hexagon, let's start by drawing that diagonal, where when we were looking for the area of the hexagon, we found that this angle here is going to be 60 degrees. Next, let's go ahead and draw these lines to make a triangle here on the left and another triangle here on the right. Since this portion is the radius of the semicircle, and so is this, if two sides of a triangle are same, then the two opposite angles are same. And if two angles are 60, then the third angle must be 60 degrees right there. Then let's take that triangle on the left and try it here for simplicity. And since it's an equilateral triangle where it's 60, 60, 60, and also the radius of the semicircle is 1, it's going to be an equilateral triangle with sides of length 1. And as I had gone over, to find the area of the equilateral triangle, instead of drawing a height and looking for the height using the Pythagorean theorem, rather you want to go ahead and use the area of an equilateral triangle formula, which is 1 squared, the side of the equilateral triangle, times root 3 all over 4. And we have a sector of a circle right here. Once again, that's the center of the semicircle. And since this triangle has 60, 60, 60, just like the one on the left, we have 60 on the left, 60 on the right, which means that this angle, the central angle of that sector of the circle, must be 60 degrees as well. There it is. So if I write down 60 here for the angle, and again, because that's the radius of the semicircle, we have 1 here. To find the area of the semicircle, the formula is pi r squared, meaning you take the area of the circle, and then you multiply by the fraction of the sector takes up within the circle, which happens to be 60 degrees out of 360. Then what we do is we add these two, which will be the triangle on the left, root 3 over 4, plus the sector in the middle, which is going to be this right here. However, we need to go ahead and add one more, the triangle on the right. So if we add the triangle on the left, sector of the circle in the middle, and another triangle on the right, which has an area same as the first triangle on the left, which is root 3 over 4. And if we add these all up and simplify, we end up getting root 3 over 2, because root 3 over 4 plus root 3 over 4 gives us that root 3 over 2, plus the pi over 6, because the 60 and the 360 reduces to 1 over 6. So there you go. Now notice that we have that exact same shape over here as well. And again, up here on the right, here at the top left, and lastly here on the left. So we have this root 3 over 2 plus pi over 6, 1, 2, 3, 4, 5, 6 times inside the hexagon. Then to find the total unshaded region inside the hexagon, what we're going to do is take 6 and multiply root 3 over 2 plus pi over 6. And if you take that 6 and distribute it into the parentheses, we end up with root 3 root 3 plus pi. Now let's go ahead and complete this question by taking that area of the hexagon that we found earlier and take away this unshaded region. Now then finally, to find the area of this shaded region, we want to get the area of the hexagon, which was 6 root 3, and take away the unshaded region that we just found, which was 3 root 3 plus pi, where if you go 6 root 3 minus 3 root 3, we end up getting the 3 root 3. And because the negative applies to a positive here, we end up getting that negative pi, where the final answer of that shaded region is going to be 3 root 3 minus pi.